talk a little bit about weather. We'll use this in the context of mainly for paddling, but the same thing could be used for hiking, could be any type of outdoor activity. It's kind of the same, well, it's weather. So let's get started. So tonight we're going to talk a little bit about what's going on above. We're going to try to keep it as simple as we can. There's a little bit of science at the beginning, and then we'll try to make it as practical as we can. We're going to start to get into some weather observation, short-term forecasting, so kind of, being able to look up above and kind of semi-accurately guess the weather for the next 2 minutes type thing. We're going to talk about some lightning, and we'll look into forecasting in particular, like where you find it and how you break down when you read it. So that's kind of the big hits that we're going to cover tonight. So you're definitely not going to become, this is my initial warning, you're definitely not going to become these two. It's not a meteorologist course because people actually go to school for it. So keep that in mind. We'll try to keep it as simple as we can. When we talk about weather, I try to frame it, sometimes people just think about it as its own individual piece, but I try to frame it in the context of the other two big bubbles around trip planning. So navigation, risk management, weather, they're separate but similar. So weather really ties into risk management of should we go out paddling today, should we not? It ties into navigation, like what direction should we start with, wind and things like that. And so it's just part of two other big pieces when it comes to trip planning and kind of figuring out what you're going to do for the day or for the next couple of days. And as paddlers, when we think about weather, we're kind of really interested in, there's a lot of weather information that's available to us, but when we think about it, we're only interested in kind of four basic things. So wind direction, that's a really obvious one. So which way is the wind going? Temperature, so how cold or how hot it's going to be. The wave height, which is tied into wind direction. So if the wind's blowing a certain direction, you might get hardly any waves or you might get a lot. So the wave height is a key thing. And whether it's going to rain or not today. Some of these are more critical than the others. So temperature is nice to have, but it's not all that critical in the grand scheme of things. But certainly wind, wave height, and precipitation is a real key thing. So if we were going to boil it down, those are kind of the four things that really pay attention to in forecasting. So there's a lot of weather science and that type of stuff, and kind of trying to break this thing down. We can talk about weather at a global or continent level. So big, huge weather systems that affect the entire continent or weather that affects the entire globe. There's more regional weather, so systems and types of weather that affects Southern Ontario or half a state or an entire province. So there's different types of weather that affects things at a regional level. And then there's stuff that affects us at the local level. So systems or weather that might affect you at one end of the lake, but not affect a campsite at the other end of the lake. So we're talking hyper-local, regional, and global stuff. So that's how we'll kind of organize this content now. So let's start with the big picture, then we'll get down to the much more practical regional and local weather and stuff you need to know about that stuff. So what causes weather? So what's the biggest influencer on weather at a global level? And that would definitely be Mr. Sun. So Mr. Sun brings in, there's a pile of energy that comes into the Earth's globe, into the globe every single day through sunlight, and you get heat from that. And that's what's called a thing called differential heating. And there's obviously a whole lot more science in this, but we'll kind of keep it as simple as we can. So the idea that you have the Earth is round and not flat, and the sun's rays don't fall evenly all over the Earth at the exact same time. So some parts of the Earth is on at night, and sometimes during the day. So certain parts get heated faster than others, and the land heats up faster than the water, and the Earth is spinning. And so you get all these really weird variables, which is what part of the reason why weather is such a complex machine, and it's really difficult to predict what's happening outside of the next couple hours or couple days because there's so many variables. But when you really boil it down, it has to do with the fact that the Earth is getting energy put into it at different temperatures and different rates at different points on the planet. If everything was the same and the Earth wasn't spinning, then you wouldn't have the same type of weather effects that we have right now. And that's just called differential heating. And so this differential heating you get a lot of cool air and you get hot air. And we know that what happens with air when it gets hot, it rises. Okay, so what that does is this differential heating causes air that's hot or cold to either rise or fall and move around the earth. Some of it's in fairly predictable patterns, but because you're spinning on top of that, it throws a layer of chaos into it.
Pickle hands.
No, this one's the pickle hand.
Yeah, someone's
Okay, thank you. Yeah, no, I'm full right now still.
Okay.
Thank you.
Yeah, no worries. I'm also gonna bake some cookies.
Okay.
I'm just gonna try to mute everybody's.
Now you're talking.
Yep, I'm gonna bake some cookies, and then we're.
There we go. So we get this differential thing. So what happens is at the equator, where in theory it's kind of the hottest point, it's kind of a simple way to start with this, is at the equator level, the air heats up, so it rises up to the top of the troposphere. And as it rises, it cools and condenses, turns into clouds, and it rains. So we've got this right at the equator level, you've got a lot of updraft and air is rising up, but it's really humid air. And so it rains a lot, which is part of one of the reasons why rainforests tend to be at the equator area, because there's so much uplift, condensing, and rain pouring back down at the earth. So what happens is it gets to the top, it's cooled down, it has to go somewhere, so it travels across the top of the troposphere, and it's nice, it's cool air at the top, and when it cools down, what happens? It sinks. So the air collapses, falls back down towards the earth, and the air that collapses back down is cool and dry compared to the air that's rising up. So what we get are these cycles where it's picking up moisture as it travels across, rises, condenses, rains, goes across, dries out, falls back down. So you get these cells of cyclical air at the equator level. You have one that's a little bit farther up, and the same thing is happening. So it's falling down, it's traveling across the Midwest, it's picking up moisture, and it starts to warm up, and so it rises again, and you get this other kind of band of high levels of moisture, which is part of the reason why Vancouver Island is in a rainforest area, and across the Great Lakes, we tend to get a lot more rain than farther south or farther north than us. So you get this cycle of air that's traveling around. And then at the polar end of it is the same thing is happening. So cool air is falling at the polar sides, traveling down across the land. So we get cold air, cold, really dry air, which is part of the reason why in the wintertime, when it's really cold, you get those vortexes of air that's coming down from the polar regions. It's those really super dry, but really cold days that air is coming down from there. So like I said earlier, there's a lot more science involved in this, but this is kind of just a really high level diagram that shows the different various heats causes these cycles of air to travel around in kind of semi-predictable patterns. This leads to other things like, we don't have a lot of time to get into it, but it leads to other things like the polar jet stream and a few of those pieces, which helps drive big giant weather systems and pushes them around the earth. So these cycles, with the earth spinning underneath it, what it leads to is the trade winds. So in our particular region is as air is blowing up towards the next band up towards the north, the earth is spinning underneath it. So you tend to get this wind that's kind of not flowing directly north-south. It kind of flows off to a particular angle. So here in Ontario, or in North America, weather tends to come from the southwest, and that has to do with the trade winds. It has to do with those big cycles of air that's traveling around. Does that make sense more? Does that kind of make sense? If you're confused, definitely put a note on the chat box and we can kind of break it down a little bit. So, so that's just a very, very high level breakdown of kind of how systems affect at the global level. But while this is important information, it's kind of just nice to know information. The real practical stuff is at the regional or the local level. So stuff that affects us regionally, there's a couple pieces that we'll talk about, and you guys have probably heard people, like on the weather when they're breaking down a forecast. One of the things that really affects us quite a bit is high and low pressure systems. And this is the real kind of bread and butter of weather that affects us. And it can get complex, but we'll try to keep it simple for you. Essentially what it is you've got different types of air that's similar temperature, similar density, similar pressure likes to hang out with each other. It doesn't, the air doesn't mix really well, so similar temperature air and density and moisture tends to hang out with each other, and it kind of finds each other and groups up a little bit. So what you've got is there's two different types of systems that float around at the regional level, and we've got high pressure systems and low pressure systems, and they are related. They're named that because it's a certain amount of air pressure that turns this into a high pressure system. We don't need to get into that level of detail, but what it affects us is when there's a type of air mass that's flowing over, it's going to determine what that day or the next couple of days is like. So if a high pressure system is moving over your area, which is exactly what we've got going on outside, at least here in Southern Ontario right now, is a big high pressure system that's moved in. And so we tend to get dry, sunny, a little bit of wind. Is generally cooler days, but because it gets so much sunshine coming in, it actually feels really warm, but the air is generally cooler. And it tends to be these big, giant, stable air pressure systems are within the high pressure system. The low pressure system is where you get storms, you get rain, you get high winds, you get cloudy, the temperature tends to be a lot warmer, and obviously those storms are found in low pressure systems. And so that's kind of the primer on that. What's interesting about high and low pressure system, as you can see by the blue arrows, is that wind spins around in very predictable patterns within those two different types of systems. So if you think about a high pressure system is like a mountain, the wind, and if somebody was skiing down the outside of the mountain, the skier at the top of the mountain will be going slower than the skier at the bottom of the mountain as it cycles down. So it's the same type of thing in a high pressure system. So wind that's in the very center of the high it's not very windy, but as you go out to the outer edges of the high, it gets windier and windier. What that means is that as a system starts to move in and pass over top of your house, the outer edges of it, it's super windy. And as the big H starts to move over top of your house, it's calm and there's not near as much wind. But then as the system moves away, it gets windier again because you're catching the outer edge of the high. So you'll see that it also travels around in a very predictable clockwise pattern. And the low pressure system is just like what the day is like. It's the exact opposite. So the wind spins in a counterclockwise rotation within that, and the fastest winds are at the very center of the low. So as a low starts to move into your area, it's windy, and as it gets closer and closer to the center of the low, it gets windier and windier and windier, and then as it passes over, it dries off, or it dies off as well. What's interesting about them is that you can see here is if there's a high that's near a low, it's kind of, you get some storms that are big and some that are super big and some that are not so much. So storms require energy, and energy comes in the form of wind and air. And so if there's a high that's nearby, you can see the arrows, it kind of flows and feeds into this storm. And so that's why, one of the reasons why some storms could be nice and small and other storms could be hurricanes or typhoons. And it all has to do with other systems that are pouring energy into this one particular one. Does it make sense so far? Okay. So what it means for us as paddlers is when you're listening for the weather or you're reading the weather and they start to talk about a high pressure system or a low pressure system, the one that you really want to pay attention to is when they talk about a low pressure system moving into the area, because we know that it's associated with higher winds, generally rainy day, cloudy, not quite as nice. A high pressure system, it's going to be an awesome day and out on the water, so you don't need to be quite as red alert towards that. It's lows that you need to really pay attention to. So if we look at and we go into a low pressure system itself, the next big concept, we talked about high and low pressure systems, but within low pressure systems, there's different types, another type of piece I'll introduce, and that's called front. And the name's not important for any of this stuff. It's the concept is the thing that you need to keep in your mind. And there's two different types of fronts, and there's one called a cold front and one called a warm front. And essentially a front is just a fancy term for the boundary. You can see there's the boundary between different air masses. And so within the low pressure system, there can be different air masses that are spinning around. And as we talked earlier, how different temperature of air doesn't like mixing really well together, they tend to stay clumped up. And so it moves around in a big group. So that boundary in between that is called a front. And the boundary where the two air masses bang up is where there's going to be conflict and there's going to be storms. And so when you're thinking about stuff that affects us, like where the storm is actually going to be, it tends to flow right along the front of either the cold front or the warm front, and where that boundary is. So because there's a transition between those air masses, so things are super unstable as the one air mass leaves and the new one comes in, that transition, the front, that's the unstable air, and storms hang out in really unstable air. When you're in the middle of one of the types of air masses that are there, things are okay, because they're not going to change a whole lot. What you've got is what it's going to be for a little bit, but when it transitions is where it is. So let's talk a little bit about warm fronts. So the difference between it, before we just jump into that, is a warm front or a cold front. So a warm front, essentially the difference in naming between those is whatever the air is coming in to replace what's currently there is what's going to happen. So if you're up at the top here in this map, and you're up, Sudbury is right up in this top section here. You've got cool air up above you. And as that low is spinning around, it's going counterclockwise. It's going to pull in warm air from the south and it's going to come up. So warm air is going to come in and replace what you've currently got. So that's where it is a warm front. And the opposite, if you're down in Toronto or let's say Hamilton, where you've already got warm air already and cold air is coming in, it's called cold front. So that's the primary difference between those two pieces. It has to do with the air that's coming in is what it's named after. And the behavior between those two is radically different. And how it presents itself in the type of storm that it brings us is night and day. The first one is warm fronts. And warm fronts are great because they're kind of this storm that comes through that's kind of slow and gentle and great for camping in the sense of if you're going to get one or the other, it's the better one to get. So we got here is a little example of a warm front that's moving into our area, and we've got a little tent down here in the corner. And if you were looking up straight above, if you're looking straight above you, you can see as time travels, this air mass is starting to move in, the warm air mass, and this is a period of probably 15 to 24 hours for this cycle to move through. If you're going to look straight up at the very beginning, you see really high little wispy clouds. And as the warm front starts to move into the area, those clouds start to group up together and they lower down. And eventually they get lower and bigger and they clump together, you're going to get rain underneath that. Rain, what happens is warm area that's moving into the area, it's kind of slow because it's tired and worn out. So it moves into the area kind of slowly pushes the cold air out of that area, and you get this kind of big wedge shape that you can see between the two air masses, and that boundary is where those clouds are forming. What does this mean for us as paddlers or people doing stuff outside is if you look up, we'll talk a little bit about clouds in a second, if you look up, you can start to see the clouds that are real high wispy level. You know there's probably going to be a change in the weather in the next 24 to 36 hours, but you pay attention to that and you go, oh, now they're getting closer and they're getting lower, and eventually it starts to rain. And it comes into your area slow, which means it's going to leave the area slow, which probably means that this type of storm is going to rain anywhere for 12 to 24 hours, and then it's going to be gone. So that's kind of very textbook type rainy day with not a lot of wind, really gentle, and then it's gone and you've moved on with your life. So if we go to our photo here, we've got this low pressure system is moving around. It's pulling in moist air. It's going to displace this cold air that's currently up here. So right along the top of Algonquin Park right here, they're getting the warm front, and it's moved in. It's probably pouring rain just north of the park up in this area, that whole band right there. And then farther south, it's already rained because the system's already moved on. So that's called a warm front. And you'll see them, and once you start to notice them, it's really textbook. It happens all the time. especially here in Ontario and the Great Lakes. If we flip and we take a look at cold fronts, and we can see here, we've already got warm air that's already in our area. So warm area that's really, it's got a lot of moisture already in it. And what's coming in to displace it is now cold air is coming in. Cold air is the almost exact opposite of warm air, which means that it comes in super fast because, you know, it's cold, so it runs around and tries to warm up. So it comes in, and it's, because it's cold and dense, it pushes all this warm air. See the arrows going up right here? It pushes all this warm air high up into the air. What happens when it gets up there? It cools and condenses, and it turns into a big giant storm. Look at that go. Boom. These move into the area where you're camping or outside doing stuff really fast. And because it moves in really fast, gets a huge giant storm, it's going to leave really fast. These are the types of storms that you see, kind of a classic thunderstorm late in the afternoon, and it pours rain like crazy. We got a lot of wind blowing all around, and 20 minutes later, sun's out, birds are singing, and the puddles are drying up. So that's a cold front that's come in because the air that is getting pushed out of the way, cold air is doing all the work pushing that warm air out of the way. On the backside of that storm, the temperature will have dropped quite a bit, probably 5 or 6 degrees, and the humidity breaks, and the air is cool and fresh. So that's a classic. You find them all over the place, certainly in southern Ontario, in the deep south for sure, where there's a lot of humidity. You get cold fronts that are moving into it. And so if we go back to our last time we see this bad boy, we've got the cold front, and it's by kind of blue prickly line. That's kind of the way that it used to get described more on maps. But so we've got all this warm air that's currently sitting over Hamilton. This low front pulls in the cool, dry air from the northern area across Michigan. And as this cold front sweeps across southern Ontario, you've heard them on TV where they talk about the system's going to come in and push out the hazy, humid day today, and it's going to break. And that's exactly what they're talking about right here, is a cold front has now moved in, pushed all that moisture out of the air, condensed it, and put it into the ground through rain. And now you got cool air that's moved into it. So these are the two big concepts. We got high and low pressure systems that move weather that storms travel in low pressure systems, and the high pressure systems help move the whole thing around. They're moving around the earth because of the trade winds that we talked at a global level, the differential heating. But we got high and low pressure systems, but within low pressure systems, you get these cold and warm fronts that happen. So this is really, you see this all the time, and pay attention to the clouds. We'll talk about it in just a sec, and you'll start to see these things start to line up in real life. Yeah, so that's kind of the regional side of things. But if we get into kind of the real practical stuff, so that stuff's good to know because you can stand at the dock and you think, all right, should I go up paddling for today, or what should we do? What's the weather going to be like tomorrow or the next couple of days? Is you can start to make predictions based on what the clouds have presented to you, and you can decide, oh, it looks like a warm front or a cold front, and we need to decide what to do based on that. But if we get down into like the real local type of weather, and that's the stuff that you're seeing, and we tend to make most of our daily predictions on weather is based on that. And the real, the window to the weather soul is through clouds. The clouds tell us a huge amount of stuff about what's happening upstairs. And so clouds are essentially just the physical signs of an invisible atmospheric process. And it sounds very highfalutin when I saw that. And it's basically, once you start to understand some of the patterns about clouds, and some of it you already know just on instinct, but being able to kind of see the clouds and kind of make a prediction certainly goes a long way. So if we think about clouds, there's a lot of clouds, and people who are there's like meteorologists who study clouds, and there's a whole bunch of pattern for how to name them, and they do different things and all that type of stuff. But if we really want to kind of get down to it, there's 3 different types of clouds, and there's 3 different heights of clouds. So if we just want to boil down to something that's useful for the common man like us. So the first one is just called cirrus clouds, and the name is not important. It's a Latin name, but it means tendril or hair. And they're those high wispy clouds that you see up in the sky. Mare's tails, as they're sometimes called, but they're super wispy, looks like feathers way up high. We'll talk about what they mean in a bit. You've got cumulus clouds, which are heap or pile. So they're those big classic puffy white clouds. And the other one is you have stratus clouds, which is layer or sheet. And they're the clouds that cover the whole stratosphere. So they're like a big giant blanket. And knowing what you're looking at, you can get down to just these 3 pieces to really tell us what we want to know. So we talked earlier, there's 3 different types of clouds, and there's 3 different heights of clouds. So what you can see in this little drawing here, we'll ignore the huge, big, giant white one. We're going to come back to that bad boy in a bit. But if we, there's upper level clouds, there's mid-level clouds and low-level clouds. So upper level clouds are stuff like the cirrus clouds. They tend to all be really wispy, but they can still be clumpy and they can still be layered-like, but they're way up at the top of the thing. And as soon as you look at them, you're like, wow, those are higher than ever. But they're anything over 6,000 meters. So they're 6 kilometers and above in there. Essentially, it's just frozen ice. So that's really what you're seeing up there is just ice crystals. At the mid-level layer, you still get clumpy and you still get layered. They tend to be a little bit thicker and they tend to be grouped up together. You don't get the wispy little clouds to the same extent because the wispy clouds form because they're ice and they start to melt at the lower level. So you're starting to really just get into the cumulus clouds and the stratus layer-like clouds. And these are kind of at 2 kilometers to 6 kilometers. And you've got a mix between of ice crystals and water droplets, depending on what you are there. And then at the low level, you have everything from big, giant, puffy clouds. You got, it's all water, and you got fog, and you got a few things right all the way down to the ground level. So if we go back to it, we have our 3 types of clouds and we have our 3 heights, and putting those in combination will tell you what is likely going to happen. So talk about upper level clouds. So what does it mean for us today? If you're seeing these types of clouds, that means that it's going to be fantastic for the next little bit. Certainly today is going to be a great day. Maybe this afternoon it might change a little bit and you can keep an eye on that weather. But the upper level clouds, you're not getting any rain out of that upper level cloud stuff. So it's a great day, get out on the water, but you might expect a change in the weather in the next, potentially the next 24 hours. It doesn't always work, but it often does. And so you're going to look for a warming trend and you're going to look for clouds and rain moving in that next little bit. But today it's fantastic. So get out there and enjoy it. This is kind of a quick example of some upper level cirrus clouds. It's all wispy. And when you see a plane that's flying by, that's leaving the contrails coming out the back, and that's just the moisture that's coming out of the engine that's frozen, and it's turned into not a cirrus cloud, but it's the exact same concept of what's happened. The little bit of moisture that's up there is frozen and turned into that wispy look. The mid-level, what does it tell us? So once you see it starts, clouds are now grouping up together and lowering, you've now got a trend, and you've got a weather trend that you're able to make a really good prediction on. So we know it's going down a little bit, and maybe it'll continue to go down. So what this tells us is that we got unstable air that's moving into our area because these kind of clumpy or the layer-like clouds are coming in. And the warm front is that ramp of wispy clouds at the top, and as it moves in, it gets lower and clumpier. We're now, the weather systems get closer. It's probably only 12 to 18 hours away. So yeah, it's probably still going to be a great day today, but we'll keep an eye on it and see what it does. This tends to probably be a little bit higher winds than yesterday because you're now, the leading edge of the system is moving in, and you're going to get a little bit more wind than maybe it was when it was just the upper level clouds. And then our low level clouds, well, the change has already happened, and it's either underway or it's just happened already. And this one is, it makes sense. You look out the window, it's raining or it's super cloudy, you're going to reach for an umbrella. You're probably not, unless you're looking for storms, You might not be out interested in going to paddling today, and you want to, or if you're camping, you're going to sit in your tent all day. So this is the low level clouds. And within this, you've got, again, you've got the big giant puffy clouds that you could see, and you've got stratus clouds. They tend to fill the entire sky, or you could have fog right down at the very ground level for that. Okay. So at the upper level, the higher they are, the more the weather is going to be stable, is kind of a general trend. So if it's at the real high level, your 24 to 36 hours is going to be great. Once you start to see them coming down to the mid-level, you might be thinking definitely this time tomorrow, it's probably going to be cloudy, maybe some rain, and then it's the third stage moved in, which is the low-level stuff. Okay. Any questions so far? Let's deal with our last guy. And so let's talk in particular about cumulus clouds, and then we'll talk about big storms coming out of them. And cumulus clouds, as we talked, are these kind of puffy clouds. And the reason why they form on really hot days and clouds form is because it's the visible sign of vertical lift of air underneath. So in this case, we've got a field here, and the field has a lot of moisture on it, and the sun heats the field, and it evaporates and heats the air. And so what happens to the air? It rises. And as it rises, it turns into a cloud. And right there. And if there's enough moisture and enough vertical lift, that cloud's going to get bigger and bigger and bigger. Maybe it'll blow away, and then the cloud will disappear because it'll heat up and evaporate into the atmosphere. It all depends on how the day is going to go. But looking at this picture here is kind of a real classic summer weather day. You got all this vertical lift. So that's what it's telling you, that when you see these types of clouds, that there's a lot of vertical lift. If you were a person who was into gliding, or you were a hawk flying, you would pay attention to these types of things, because this is one of the reasons why hawks can glide, or those gliders cannot glide, because there's all this vertical lift, which is helping them stay upright and pushing them higher up. I remember someone told me, you got this big blue arrow in the middle, is where there's spaces in the clouds is one of the reasons why clouds don't just automatically clump up, is because there's downdrafts in this particular blue arrow right here. There's a downdraft that's right here that's going back down. It's creating a big cycle here is what's happening. And this downdraft is punching a hole in the cloud and breaking them apart. Eventually, it'll overcompensate and group up together. But for now, these downdrafts are keeping the clouds kind of compartmentalized apart. Okay? So these cumulus clouds are great for us as paddlers. You really want to. These are the ones that you want to pay attention to on an afternoon. When they're small like this, it's not a big deal, but keep your eye out on them and see if they get bigger as time goes on. So check in on them in the next 15 minutes. So what's happened to those clouds? Do they blow away, or do they stay the same, or do they get bigger? Because when they get bigger, those are the ones you definitely really want to pay attention to, as you do not want to get into the system. So when these big cumulus clouds, and they add a suffix to the end called nimbus, which apparently means dark and scary. So you've got a cumulonimbus cloud, and it's these things become the big storms that as soon as you see these happen, you need to get to shore and get somewhere where it's safe, because they're the dangerous ones. So these types of clouds, when it's enough moisture and enough humidity, that it turns into a small cloud and get bigger, bigger, and bigger. Now you've got a huge, big, giant storm. There's a lot of energy in this system right here, and this system is, well, in this particular case, right at the bottom here, it's already raining somewhere way out in the middle of this lake, but it's not raining in other parts. So the cumulonimbus clouds, they're the ones who really, like I said, I can't stress it enough. They're very unstable clouds, and they're the ones with really high winds and potential for lightning inside of them. So what happens is, the way these form is they blow up really fast and they collapse and come apart really quick. So what you've got here is there's enough heat and enough moisture underneath that, and it's feeding into that entire system, and a cloud starts to build. And if it's not big enough, that little puffy cloud just kind of moves away. But if the conditions are ripe and correct, more and more moisture flows into the underneath of that thing and builds, and you got a big giant tower late in the afternoon where it's hot and a lot of moisture. You can see all these arrows in here got a lot of vertical lift. So wind is blowing up and wind is blowing down. And when that shears against each other, you get a lot of static electricity, which leads to lightning. And that is very turbulent air inside of there, so it's going to blow out in all different directions. So if you're on the water, it becomes very turbulent water, and all of a sudden you're holding on to the canoe or you're holding on to the kayak, and you're like, oh, all right, we got to get out of here, because the downdrafts are really, really powerful. And you can see this gets big enough, it gets really unstable, and water starts raining out the bottom, kind of like if you're just going to hold up a full sponge of water, it just starts pouring out of the bottom. Exact same thing happens, and eventually the cloud dissipates and collapses in amongst itself. All right. Like I said, these can blow up in 20 minutes, and they can collapse just as fast, depending on just how dangerous they are. But it's the wind and the lightning is the most dangerous part of these guys. So here's a little guy here. This is a time lapse. Look at this guy blowing up here. And it goes right to the top. And this is probably over a period of about 12, 13 minutes, I think is what it is. So what you can see is the cloud, there's all that field underneath, there's moisture coming out of that forest or the field under there, and it's blowing right up to the top. And there's another one coming in the back here, and it's blowing up, and the winds are starting to blow it all sideways. So you start to get this big giant anvil shape across the top because it hits the top of the troposphere, and there's kind of an invisible barrier, and it can't go any farther. So it's kind of like smoke in if it hit a ceiling, it would just travel across the top. And this is exactly what's happening right here. We'll watch it one more time, and then we'll move on. They're awesome. So blowing up, it'll probably, in this case, it's probably going to start raining just in a couple minutes. Yeah. Cumulonimbus clouds, they're really cool. So my super patented afternoon storm calculator is these things happen at a very local level, and they tend to be as big as Southern Ontario, where they talk about big storms moving in from Hamilton in through Toronto. We hear these types of warnings all the time. And it's essentially what it is. It's a mini cold front that's moving through super fast is what's creating this, but it's a small area. But the storm could be as small as your campsite, and the campsite a couple of kilometers away at the other end of the lake doesn't get anything. So they could be super local. They could be kind of regional as well. Essentially, these storms need two things to really get going. It needs a lot of moisture and humidity, and it needs a lot of heat. So we talk those afternoon, really hazy, like high humidity days, you're gonna likely get some type of storm that's coming in. As my scientifically calculated Venn diagram here is, so you've got a lot of heat and the air is moving up because it's hot, and you've got a lot of moisture and humidity in that, you're likely gonna get a big storm. So when you're out paddling, you should be thinking, keep in the back of your head, okay, it's really hot, it's really humid, I should be prepared. When do they come up? It's late afternoon. It's a typical time when those tend to happen. So anytime after 2, 1 in the afternoon, you're going to see that coming in. They don't really happen later in the evening because there's often not enough heat to kick the thing going. So you could be in a situation where you could have a lot of heat, but not a lot of moisture in that air. So you got really hot, dry air. You're not likely going to get really intense storms moving through your area. So an area where you would find this type of thing, somewhere that's really hot and dry. So the desert. In a desert, you don't tend to get really violent storms. Rain will come through, but it tends to not be super violent storms because there's just not enough moisture in that air to generate those big giant clouds and air and wind and lightning. So in a desert, this isn't quite the same issue. Likewise, if you were at the opposite side of it, where you were in an area that was cool, but had a really high moisture, or you're likewise not going to get the same storm. They kind of need to be in a bit of balance. So if you were somewhere in a rainforest, like in BC, they've got to be aware of lightning, aware of storms, but the storms that come through are not the storms that we tend to get here in Ontario, where it's a much more high heat, high humidity type situation. You go down to the deep south where Tornado Alley could be, it's the exact same thing. There's a lot of moisture and a lot of heat. It's going to turn into a big giant storm. So those guys have to deal with that type of thing all the time. Okay. So keep in the back of your head that when the conditions are kind of ripe, you really want to be and pay attention to that. Okay. Oh, this is good. All right. So 4 signs of let's see if I can pronounce it, imminent weather change. So how do you know the weather's going to change? And we're talking like the next 15 minutes, like where there's enough time for you to get off the water and find some shelter. There's kind of 4 classic signs that something's going to happen. First one is the wind. So just before a storm happens, you're going to really pay attention to the wind. The wind's going to do 2 things. The wind is going to increase in speed, and it's going to change direction. So that's the second one. So increase in speed, and it's going to change direction. And this one is probably the most obvious sign of the 4. And so if you're out paddling and all of a sudden the wind is getting really strong in a really short amount of time, you need to be aware that something's happening, especially if the wind has changed direction. Then now you've hit the double piece and something's definitely happening. So as storm starts to move in, it's pulling in air and energy from it. And so it's blowing in from different directions under the clouds. And it's part of why the wind changes direction. There's more to it than that, but that's good for tonight. And in particular, if the direction change happens in a counterclockwise direction, okay? So if the wind is blowing out of the north and you're paddling along and it's coming out of the north, and then all of a sudden it's now changed and it's coming out of the west, it's changed in a counterclockwise direction. And that tends to it tends to be a sign of more intense storms than if the wind had changed in a clockwise direction. It's not the important part of the whole thing. It's just kind of a nice to know. The real key is that increase in speed and change in direction. Those 2, you should be thinking about getting off the water for sure. The second one is a temperature increase. As we talked about, when a warm front starts to move into your area, you've gone from cool air to warm air, it starts to move in. And just before storms, the temperatures will often increase. The tricky part with this is like you need a thermometer and you need to measure it. So this is probably the least of the 4 that you're really going to pay attention to, because not too many people are sense enough to go, oh, it's 2 degrees warmer, I can feel it. So it doesn't really happen, but wind is really easy. Temperature is another one. Another one is air pressure drop. So just as the storms, low pressure systems move in, and as cold fronts move in, the pressure will drop. And so if you had a barometer, then you could measure what the air pressure is and you could see it happening. If you had an old man with bad knees, they would definitely tell you that there's a storm coming in. So, when you're on a trip, always bring an old man with you and to tell you when the storm's going to happen. And then the last one is clouds. So the cloud trends are grouping and lowering. And so these are the 4 big, really easy to see. One of the 4, the 2 that are hardest to measure and see are temperature and air pressure, because you need some type of external tool to be able to tell you, but your eyes can tell you what's going on for wind and clouds. So really pay attention to those 2. And this is not rocket science. So it's fairly easy to pick up, and wind is really the receipt for this piece. Okay. Dun, dun, dun. All right, let's change gears a little bit. Let's talk a little bit about lightning safety. I always like to try to end it on a real positive, upbeat note. Dun, dun, dun. Okay. So lightning, it's, if we think of bad things that are going to happen to us, there's rain on my trip and I got wet, and then there's wind and I got cold. And those are not too bad. We like to complain about that, but lightning is the one that you should be the most scared about for sure. And so lightning is, I always like to talk about it because it's an issue here in Ontario, and I know people are we have people calling it from all over the place, but lightning is, in some areas, it's not quite of a big deal, but for us here in Ontario, for sure, it's a big deal. So I always like to talk about it, and some general principles. Lots of people get hit by lightning, and it's predictably unpredictable. And there's times when you should be thinking, I need to go indoors, and why some people or something gets hit by lightning and other things doesn't is super unpredictable, and which is one of the reasons why lightning is super dangerous. So we don't know where it's going to strike. If it does, it's definitely like a lottery. It doesn't always strike the tallest thing, because if it did, it would, always hit the CN Tower all the time, but it doesn't hit other places for it. So what's happening up there? Just kind of breaking it down to a real high level, essentially is this. So we have a big storm cloud that's over top of us. We have positive ions and negative ions. And what happens is that the negative ions are trying to ground out and trying to get to the ground. to try to ground out the entire thing. That's kind of the real high level of what's happening up there. So what happens is the positive ions are attracted to the negative ions. So they send these little leaders of that travel up above there. And it usually comes out of at any point. So the tops of trees or the tops of a tent or the top of your head. And this all happens, this kind of these tendrils float up. And this happens in a couple seconds. So they start to float up and there's a little bit of a race, and there's these negative ion tendrils that are traveling down. And essentially, whatever one wins the race is where the lightning hits, which is part of the reason why lightning is so unpredictable. So in this case, you think this tree is the tallest, so let's stay away from that tree. Let's go stand somewhere else. But it all depends on whoever wins the race for it. And okay, so there's obviously more to it than that, but that's my quick version of it. But you've got so that's the thing to keep in mind. So when there's thunderstorms, you need to be really aware of it. Now, there's some general principles about good places to be. There's good places, and then there's bad places to be. So if we looked at this kind of general mountaintop with some valleys and a lake and a car and a house, all conveniently stuck in the area here, some places that are super dangerous that you don't want to be. And this is an issue that affects people who are in the backcountry, in the mountains for sure, as much as people who are out in the middle of the lake. So this affects a lot of different people for it. So generally, some of the real obvious spots you don't want to be, the tops, the hills, a big giant tree, because it's statistically going to get hit likely a little bit more. Here's another big giant tree and another one down here. They're in the super dangerous category. The least objectionable alternative version for it is the next ones where you kind of don't, in a worst case, if you had nothing else, it's okay, but it's still not great. So down the side of a hill, in amongst a clump of trees, in a valley, and it has to do mainly because water will flow through there in a storm, and electricity likes to travel through water. So this one might seem like a great spot, but you just kind of got to be careful with it. If you're in a mountaineering situation and you're descending and you're going down a valley, it's the same thing. You kind of really need to be careful with that type of thing because water travels in those same valleys. So we call it in the least objectionable alternatives. And then the last one is the safest spot. And so if you take a look at this, there's really only two safe spots, and that's in a car and that's in a house over here. Okay, so there's, but those aren't obviously not nearby all the time. So you need to kind of choose your own adventure and pick the least of a bad spot. The general principle is you're off the water and you're out of an open area, but you don't want to be standing under like a metal shed and those types of things. So we kind of got to really think about it. So when there's if the conditions are ripe for storm, you need to think about, what do I do if lightning is a real thing? So how do I get out of this type of situation where I am? So big wide open areas, which is usually for us is out in the water, is definitely a no-go. Storms are really finicky, and that especially if you're paddling along and not paying attention, they always kind of creep up behind you for some weird mystery, and all of a sudden you look over your shoulder and there's a huge big giant storm. If it's dark and scary, you need to be getting indoors for sure. Okay, in the deep south where lightning is a huge issue for sure, where humidity is much bigger issue for them farther south, they have a government motto plan that somebody in government came up with, was when the thunder roars, you go indoors.
I ate it.
Yeah, so you need to definitely keep an eye out for that type of thing. So as soon as there's thunder and lightning, you should be thinking about getting indoors. So this is our rule for the outdoor industry of like, when should I think about going inside? And we call it the 30-30 rule. And it's pretty easy to remember, which makes it great. And this is the industry standard for leaders on the water. And so you guys should be thinking about it as well. And essentially it's this. So the time between a lightning flash and hearing the thunder, if it's under 30 seconds, it's time to get off the water. So you see the lightning way across the lake, start counting in your head. And if it's under 30 seconds, you need to get to shore. And essentially that 30-second mark is roughly the storm is 10 kilometers away. Because just by how much time it takes for that sound to get to you, It does about 20 kilometers an hour. It's kind of the rough version for it. Okay, so if it's under 30 seconds, you're off the water, and then you're off the water for 30 minutes after the last thunderstorm. So, or the last thunder is heard. So you need to, once the storm passes, you need to start to pay attention a little bit and keep an eye on your clock. And every time it thunders, you just reset the clock and you just hang out for another 30 minutes. There's kind of a funny thing happens that when storms are coming towards you, everyone's in a panic to get off the water. But then the second the storm moves away, the clouds are out, or the sun is out and the birds are singing, everybody thinks, let's jump on the water right away. Well, that storm is still super close. It's just because it's moving away doesn't mean that it can't strike backwards. We have this idea that storms only send lightning forward ahead of it, but they can send lightning behind it just as likely, which is the reason why we stay off the water for a full 30 minutes. And if you're in a big, giant open area where there's, like say Georgian Bay, where you can see storms really far, then you can kind of make a bit of a judgment call on that. But if you're in an area like on a lake, or a small lake where there's hills, or in a river where you can't see what's happening over the next ridge to the side, you don't know where that storm is, which is why we wait 30 minutes. So that's the industry standard. So within 30 seconds, and we sit around, sit and gossip for 30 minutes after the storm went by. Oh, someone's got a thing for tents for camping. Yeah, so camping in a storm is an interesting one because where are you going to go? It's some tricky pieces. And so, you get a big storm in the middle of the night. And so some principles that some people talk about is sometimes if a tent gets hit by lightning, the poles, it'll run around the poles like a Faraday cage. So it will travel down the poles sometimes, but if you're touching a pole, then it can travel through you. Some of the general principles is obviously to stay away from those types of things during a storm and keep yourself sitting on an air mattress. So the idea is lightning's trying to find the easiest, quickest way to the ground. And if it's quicker to go through you to the ground, then it's going to travel through you. So you want to try to make it as difficult as you can so it travels somewhere else or hits your tent partner. It's really what your goal is. So if you stay on a thermarest, you've now got a bit of insulation between you, and the lightning will have a harder time going through you. But if your foot's hanging off the end, then it could travel through you. So just kind of some general principles is, stay in your tent, but sit on a thermarest is kind of the best. There's a bunch of different things you can look up where you sit on the balls of your feet and you crouch and you hold your ears, and there's all kinds of stuff like that. You sit outside in a life jacket under you, and there's kind of some various weird pieces, which I always think, why would I sit out in the middle of the rain? But kind of got to pick your best spot for sure. One of the things that you always want to do when you're setting up a tent is find a nice flat spot, but then sit and look above you and figure out if there's really high winds or lightning, are those branches going to fall on your tent? That's actually a much bigger, more likely scenario than you actually getting hit by lightning. So really pay attention to giant branches that could take out your tent and or you. So that's another thing to think about as well. So lightning is predictably unpredictable, and it is the worst thing. Luckily, it's statistically it's really rare. Like we think about, there's always the story of that one guy camping, or those, the story that always traveled around when we were kids, two people who were making out, lightning traveled right through them, and it was clearly God was sinning. They were sinning, so that's why they got hit for sure. So these things happen when there's always a story of people who got hit by lightning, but statistically it doesn't happen a lot, but when it does happen, it's high consequences. So you need to really be aware of that. And my last little piece is, so the reason why we keep it within the 30 seconds rule is because lightning can strike as far ahead or behind as far as 15 kilometers. And and we talk about, so that's about 45 seconds. For time to travel. So if you're in a storm within 45 seconds, you're technically within the outer reaches of what lightning can strike. So you really want to start to pay attention to that type of stuff as soon as it comes up. Certainly within 30 seconds, you're within an area that lightning's not super likely to strike, but it definitely could strike much better, like 10 kilometers for sure. So you really want to pay attention to that. Dun, 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 dun. Super scary at the end. Oh, like I said, I like to try to end things on a real high note. So with weather, this is all you need to know about weather. That's all the science that you need right there. Sucks it up. Blah. Let's take a look real quick. Let me just jump down because I just want to talk a little bit about marine forecasts, and then we are going to be all done. Where's my, we're going to look at that, and we're going to look at that. Let's pull these up. So marine forecasts, so there's two different types of forecasts when you're pulling it up on whether you're looking on the internet or pulling the old newspaper out at the library to figure out what it is or whatever. If you're in an area that has a marine forecast and you're out in the marine area, then it's going to give us specific information that's helpful to us compared to a land-based forecast. You find these essentially where there's kind of commercial industry. So you're gonna find it on the Great Lakes, you'll find it in the St. Lawrence Seaway, you'll find it on all the ocean area. And a marine forecast is really gonna pay attention to because it's written and it's information that people who are in the commercial side of things, say fishing, boating, recreational paddler, the things we kind of care about more. And it's really all about wind and direction, and it's a little bit more focused on that type of stuff, as opposed to whether it's going to rain or not. If you're out fishing, like on a commercial boat, it doesn't matter about it, but they definitely want to know about the wind. So, and it's good to compare the two. While the land is much more focused on whether it's going to be sunny, it might not talk about wind to the same extent. It'll just say it's gusty, but it might not, doesn't care so much. Okay. So the marine forecast here in the Canadian marine forecast follows a couple little patterns, and I'll whip through it real quick. And you can get this both if you have a VHF radio, it just cycles through. You've got, you can look at it online, and it gives you a text-based version of what it's coming out as. There's a whole pile of other really good resources around weather. Windy.com is a fantastic breakdown, and it really, it's obviously focusing on wind, but it's a real weather nerds piece. So definitely took a look at that. But the Canadian weather is the official one. Everybody else just pulls data from it and just presents it in slightly different ways. So whatever works for you, it's great. But let's go back to kind of the basics if you were listening to on a radio of what you're going to hear. And this is just a kind of a quick example of what I pulled out the other day. And the way that it works, certainly in the Great Lakes, and the same as everywhere else, is it's all broken up by little regions. So for us on the Great Lakes, there's Eastern Lake Ontario, Western Lake Ontario, Eastern Lake area, Western Lake area. So it's got these big zones, but it's kind of broken down. It's got Lake Huron. It's got two zones for that. Georgian Bay in particular has got southern and northern area, and Lake Superior has got one big giant, it's got two zones. The advantage to it is that it covers a big area, but that's the disadvantage. It covers a huge area. So your particular weather right in front of you might be slightly different than what they're saying. So the way it breaks down is it obviously just tells you when, a couple things that I look at is when it was determined. So this is at 10:30 back on May 11th, and it's good for today, tonight, and Tuesday. So the forecast covers the next 2 days. If it's only covering a short area, then the weather is going to be a little bit more intense. They update it more often. So, and when is it going to be next updated? 6:30 tonight. So they'll update it. So, and otherwise, this is what you're getting. So Western Lake Ontario, there's a strong wind warning in effect. And I'll just kind of read it through real quick, and then we'll just break it down so you understand what you're getting out of this, because there's a ton of little clues in here. So wind north 15 knots, back into northwest 15 near noon, increasing to northwest 20 this afternoon. Then wind diminishing northwest 15, and it keeps going from there. So the first sentence is a couple like a real quick clues out of that. So obviously it's talking about wind. It's coming out of the north, 15 knots. If you double it, it's about 30 kilometers an hour. So it'll give you an idea. Everything is in knots in a marine forecast. So it's coming out of the north this morning, 15 knots, which is a pretty brisk wind for kind of in between beginner intermediate, that kind of level paddler. Anything over 8 knots, you should definitely be figuring out where you're going. So you wouldn't be paddling in this particular one. So they say, so it's coming out of the north, they call it backing, which means that it's changing direction in a counterclockwise. So it's changing to northwest, 15 near noon. So it's staying the same, but it's changing direction. Then it's going to increase to 20 this afternoon. So it's staying the same direction, but now it's getting faster. Later tonight, it's going to diminish to 15. Then tomorrow morning, it's going to jack up to 20 again. So 40 kilometers an hour, boy, it's quite a headwind. You wouldn't be paddling in that for sure. So you can figure out the pattern of kind of how wind is going to change over the next little bit. But general pattern is it's super windy. It's going to get even more super windy over the next 24 hours. And we've got rain or snow ending this afternoon. So, and then on Tuesday, we're going to get a little bit of showers. You can see how much information they actually give towards showers. Like, it doesn't matter at all because for those guys, compared to how much information they're giving towards wind and wind direction and wind speed, because that's really that matters. So you can get a lot of information about what we're going to do today and tomorrow based out of that. And that's called the forecast. The other one is they have an extended wave height forecast. And so you could listen to it and think about it. But if you're planning a trip for multi-days and you want to see what's into the future, you can see here, and it's very generic. And it tells you, so Wednesday, wind west 15 knots, wind light becoming southeast 15 knots. So we can see this sometime overnight, it's going to quiet down and get back up again. And then something's happening on Friday. Look at that, southwest 25 knots. So you could think about, if you're on a multi-day trip, what are we going to do? Should we change our route? Of course, it's all going to change before that actually happens, but it'll give you an idea. Then the last part is, or one of the big ones, is called a technical marine synopsis. And it's a super fancy term just describing where the systems are. And you probably wouldn't really pay attention to this a whole lot. If you're on a multi-day trip or you were paying attention, what's it going to be like in a couple of days, you can pay attention to this, and because it tells you where the high and low pressure systems are, and you could track them over a bunch of time, a couple of days. There's only a handful of trips where I've been on where I've really paid attention to this. It's not a huge big deal for us. So in this particular case, the system's position, it gives us here, so at 10:30, a low of 100.9 millibars is located over New York State. So there's a low sitting over New York State. And then indented here, just so it made a little bit obvious, by 10:30 tomorrow, that low is going to move towards Nova Scotia. So it's going to go from here, it's going to slide out to Nova Scotia, which is following the trade winds, which is very, very typical. Then they talk about here at 10:30 today, there's a ridge, which is located on a line north-south over Saskatchewan. So a ridge is a high-pressure system. So think about that. And it just happens to be stretched out in a big, long line. And then what's going to happen is this is going to, let's see what happens here. So it's going to move, and it's going to slide down to what they say here by the next morning. It's going to be high northwest over Minnesota. So it's going to slide down, and the low is going to move out over there. And that's going to be the next, in 24 hours, that's going to happen. So again, it's just a really high level piece of what, giving you an idea. And I just dip into this, like I said, just every once in a while to kind of see what's going on. If I'm on probably day 3 or 4, or I'm confused about what is happening on the weather, because there's a bunch of things happening, I might think about paying attention to this. So the radio cycles through these 3 sections for, like it'll cycle through all the forecasts for all the different zones in the Great Lake. Then it'll travel through the wave height for all the different sections. And then the synopsis is for the whole thing. So it takes 10 or 12 minutes to get through the entire piece. And then if you're on one that has French, the whole thing will be in French for it. Here on the Great Lakes, it's a separate channel. So you don't have to listen quite as long to get the language that you want. All right. So what you can, marine weather, if it's a tool that's available to you, you definitely want to pay attention to it if you need to. But you can get information, say, just by getting a land forecast and talking about the weather, especially wind. But you could get it from other sites that specialize in wind, because say windy.com, which really focuses kind of the surf community is its big market that they're selling advertisement to. And so we can just piggyback off of that. It's a wonderful, wonderful resource. All right. Does anybody have any last minute questions? Because I'm all done. Type them in. Or you can unmute your mic and you can holler for sure.
I typed in one. What's a reasonable wave height for paddling, for kayakers especially?
Well, it depends how good a story you want at the end. That's the important part.
We want a happy story at the end.
So, I mean, it certainly depends on your skill level. If somebody, generally speaking, if somebody was, they're super, super beginner, like never been in before. So somebody who's at a beginner level but comfortable in their boat, I would say anywhere 6 to 12 inches, like kind of up to a foot at the most. Somebody who's more moving towards more intermediate, is kind of 1.5 to 2 feet. It all depends on your comfort level and that type of stuff, but that's kind of a rough benchmark. So if you're paddling along and you're looking at your paddling partner and the water is a bit higher than the boat, like, you're looking across, the waves are kind of that's kind of about a foot. So if it's up beside them, if the waves are in between you and it kind of gets up beside them, if it's kind of up kind of mid chest level, then that's kind of 1.5 feet. That's kind of a rough idea. So you can kind of go from there. Yeah, but then when you're done, you need to get your group together and you need to figure out the truth of how big those waves were. So start with, like, say it's 6 inches, you're going to double them to 12 and you're going to say minimum at the end. That's my trick to it. So those waves for sure are 10 inches minimum.
I thought the answer was just big enough that you don't have to paddle. You just ride.
As long as everybody has the story straight. It's like they say, history is written by the winners. So as long as everybody says the same number, it doesn't matter.
I have a question too about pitching a tent. My tent was actually hit by lightning. I was in it. I was on the thermal rest. I was okay. My tent poles were welded together afterwards.
Nice.
This was up near the delta there, near Key River.
Mm-hmm.
And somebody told me that's the most common place for lightning strikes.
Yeah, I've heard that several times. Yeah, for sure.
I was camped near a small tree. Later on, I looked online to see where is, lightning, where should you camp in lightning? And they said near near a group of small trees, sorry, not near one small tree. And I wondered if you have any knowledge about, what kind of tree would it attract?
Oh, that's, lightning doesn't care what kind of tree it is, for sure. It's
like a very tall one you mentioned.
Yeah, like I would probably pick a group of trees as opposed to a big giant one single tree. But given the option, I wouldn't camp out in the full open. I would sit under that tree. But if I had a better option, I'd take it. It's kind of a super vague answer. Generally, I mean, you've seen lightning just does whatever it wants. That's the worst part about it, is it can travel all around. It can travel over rocks. It can travel through water. It can travel down roots. It's, damned if it just does whatever it wants, So we kind of talk about there's better and worse places to be, and you kind of hold out for the best. Must have been scary.
But in the campgrounds now, some campgrounds have these wooden platforms.
Okay.
Yeah.
Would that be safer to be on the wooden platform?
Yeah, definitely be more comfortable for your back, for sure. And being up off the ground is general principle is a much better way. Yeah, for sure.
Oh, okay.
So I have a question. Especially here in the beaches area where it's get pretty windy, can I estimate by the wind how bad the waves are gonna be before I go out and find myself kind of wobbling around?
Oh yeah, to save yourself a trip down to the water.
Yeah.
Yeah, it kind of comes with experience and kind of where the area goes, like where you're at. There's some people would say there's a hard and fast rule, but I don't really believe it in that sense. But generally here in Ontario, or certainly for Lake Ontario, anything blowing out of the south for a half day is going to make it pretty wavy. But the lakes, the Great Lakes, they ramp up real fast and they die off real fast because they're 100% driven by wind, as opposed to the ocean where you get wind and swell. So it can be super calm, but it's still blowing. I would really pay attention to anything that's over 10 kilometers an hour. And if it's coming out of the southwest, you definitely would want to kind of scan it and decide whether you're going to go or not. There's a couple, if you take a look for Lake Ontario, there's a couple online cameras that can kind of give you a clue what it's like, and it doesn't really help a whole lot. But some of the sailing clubs have a little camera pointing out over the water.
There's also the buoys that you can use.
The buoys are great.
Casting buoys.
Yeah, that's a great
Can
tip.
be good for finding surf and also figuring out how still the water is. There's a couple around the lake that can help.
Yeah, for sure.
Like, last year, every time I wanted to, like, let's say 90% of the times I wanted to go paddle here, it was just way too, like, the waves are pretty, intense.
Yeah. Yeah, I mean, it's you're going to have to, find places that are either inland or in the morning or in the evening. It's kind of generally once the things start to settle down a little bit. But the buoy system is a really interesting, fantastic system that a lot of people don't tap into, and the marine forecast gets into that. Is you can there's buoys that are strategically placed around the Great Lakes and around on the ocean. They're all around the world, and they're essentially just weather buoys, and they just record data, and they upload the data every little while, and they record everything depending on how sophisticated they are, from temperature to current to wave height to swell height to wind speed and wind direction. And they're essentially just they're a floating weather station. There's there's at least 3 on in Lake Ontario, for example. There's one just south of Toronto here, and
there's one pretty close to us.
Yeah, and they're really cool because it'll give you what the wave height is. The only caveat in that whole thing is that they're waves way out in the middle of the lake, and which could be bigger or smaller than what's on shore. So, but it'll give you, it's another piece that you could take a look at. If you wanted to look for that, a nice way, NOAA, you can just Google it. It's the U.S. Weather Service, and just go for marine buoy. Start typing in that, and you'll fumble down that rabbit hole. There's a lot of really interesting stuff out there.
Thank you.
Hey, no problem. Any other questions?
Just a comment. One time we were up on Philip Edward Island, and there was a thunderstorm moved in, and then it was just gray and cloudy and rainy for 3 days. So we just stayed in our tents. Is there any way of predicting when you're going to have a week like that? I mean, it was a disappointing experience.
Yeah, for sure. I mean, that's it's a crapshoot in a sense. I mean, essentially, likely what ends up happening is in that case, it's a warm front that came through. So a low pressure system came through, which had a warm front in it. And so it moved in and sits and rains for that, up to kind of 2 or 3 days, or a day to 3 days. It all depends on how fast the system's traveling over land. The computer systems that generate the algorithms around figuring out the forecast, they're significantly better than they were 3 years ago, 5 or 10 years ago. So they can now predict 7 days with the same level of accuracy that they used to be able to predict 3 days into the future. And so their ability, and there's a new system that's coming on, and we're definitely going super nerdy, and I apologize. There's the U.S. Weather Service is bringing in a new computer system that's going to roll out over the next 2 years. That's going to allow them to push it for up to 10 days with a high level of accuracy that before was at 7 days. So, but yeah, of course, it's the one weekend you book off to go that it rains a lot. So. Cool. All right. Well, I'm all done.
Thank you.
Yeah. I appreciate you guys coming. This was definitely a record. I think we had at the top at like 56 or 57 people. Whoa. I'm pretty excited about that.
David, I just one quick question. The small craft warning, is that the 8 knots or 15 kilometer per hour?
Yeah.
Okay. So that's like for kayaking.
Yeah, for sure. So when you start to hear a small craft wind warning, it's just a certain point that it automatically triggers, and you should definitely be thinking about staying on shore.
Okay, thanks.
But then again, it depends where you're going. I mean, maybe you're going on a route that's hidden from the wind. Maybe you're going inland, and everything changes at that point.
Yeah.
But yeah, it's just a general warning.
Yeah, okay.
All right, well, thanks so much for coming.